Hello and welcome in the challenge of learning the end behaviors for your performance standard for your pre-calculus class. My first example is 5x plus 2 over x squared minus 4. And what you can actually do is type this directly into your calculator. What you go to is press the y equals button, put a parenthesis, put in 5x plus 2 in parenthesis divided by parenthesis x squared minus 4 in parenthesis. Then you press the graph button, which your graph should look like this, with your asymptotes being -2 and 2 on the x-axis and 0 on the y-axis. And this is because x squared, your exponent, is larger on the bottom than it is on the top, which causes your end behavior to equal 0 only because your y asymptote also equals 0. Now it's time for example number 2 of the performance standard end behavior. My example is x plus 2 divided by x minus 1. Once again, you can type this directly into your calculator by pressing the y equals button, parenthesis, x plus 2 in parenthesis divided by parenthesis x minus 1 in parenthesis. Once you have done that, you can press the graph button and your graph should turn out like this, with the y asymptote being at 1 and your x asymptote being at 1 also. Your x asymptote is at 1 because it is the opposite of the second part of your equation looking at the bottom of my example. Y asymptote equals 1 because of the fact that this variable divided by that variable equals 1. 1 divided by 1 equals 1. So the end behavior equals 1 because your y asymptote equals 1. Because the endpoint over on this asymptote goes off in the direction to 1. It'll get as close as possible to 1, but it will never touch. My final example of the end behavior performance standard is also probably the most challenging one. X squared minus 1 divided by x plus 2. Once again, you can type this directly into your calculator. Y equals parenthesis x squared minus 1 in parenthesis divided by parenthesis x plus 2 parenthesis. Graph it. And your graph might not look like this at first because you probably have to zoom out because of it being located at -7. The reason it looks like this is because it is an oblique asymptote. This is because your exponent is larger on the top than it is on the bottom. That's why it has this diagonal asymptote. And because of that, the end behavior equals infinity, because there is no y asymptote. Because if you notice, up here, where is this asymptote heading to? We can't tell because there is no real way to find out where it goes other than a type of fraction with slope. So we just call it infinity because it's not anywhere on the y-axis.